Gen 2. Since its reveal in March 2023, Tesla's humanoid robot has captured the imagination of tech enthusiasts and skeptics alike. Promising dexterity and the potential to revolutionize various industries, the Gen 2 has sparked a wave of curiosity. But what updates has this innovative robot received since then? Has Tesla addressed concerns about its functionality and autonomy? Let's find out. During the initial reveal of the Tesla Optimus Gen 2, the robot's movement was quite a show. It demonstrated a walking an elderly person, which was of course not the most graceful movement, but it did show some innovative potential. Walking motion as a significant step forward in humanoid robot development. Others pointed out the lack of fluidity and balance in the walking motion. There were calls for improvements in agility and overall gait for the robot to be truly practical. And now there is a huge improvement compared to what we originally saw. The Optimus is making impressive strides towards human-like walking. Engineer Milan Kovac weighed in exciting details about the robot's recent progress. According to Kovac, the current walking speed is around 0.6 meters per second, which is a significant compared to the first video of the Gen 2 back in December 2023. While this is still about half the speed of an average human walk, which is around 1 meters per second, it highlights the tremendous advancements made in just a month. Kovac went on to delve deeper into the multifaceted performance enhancements achieved by the Tesla team, suggesting there's more to the story than just walking speed. He said, "We've improved our foot trajectory and our ground contact logic. We've upgraded our motion planner and made cuts to our loop latency across. The bot Optimus is more stable and overall even during turns. We also added a slight torso and arm sway. Now, if you remember the very first presentation of the Tesla bot, it had to be held up by some sort of support carried out by 3 people, showing that the bot originally had balance issues. This was a letdown, and it faced a lot of backlash from people around the world. But now we can see the bot moving way better than we expected in such a short period of time. And performs squats now. If you ask me, this is pretty impressive. The robot's pathfinding also sparks curiosity. While the exact method isn't confirmed, some speculate it might follow a Bezier curve, a mathematical path often used in animation and robotics. Interestingly, there are faint X marks on the floor where the robot walks. These might not be directly touched, but could be markers that the Optimus uses to plan its path. This raises the question, is the oddly controlled or autonomous? While the information is limited, it's possible these markers are used by the robot's environmental analysis capabilities to navigate its surroundings rather than relying solely on remote control. Another massive improvement was the hand movement. The bot had such precise and fluid hand movements. The most captivating demonstration involved a seemingly ordinary task, handling eggs. The Gen 2 carefully reached out and picked up an egg, its movements deliberate and controlled. This wasn't just grabbing. The robot seemed to understand the fragility of the object, applying just the right amount of pressure to avoid crushing the shell. The bot utilized force sensors. Imagine super-sensitive fingertips. That's exactly what these sensors are like. They measure the exact amount of force being applied to different parts of the robot's body. This allows for a gentle touch, crucial for handling objects precisely. But the Gen 2 didn't stop there. With a smooth, almost graceful transfer, it passed the egg to its other, placing it into a crate. And what most people didn't realize was that it placed the egg exactly in the right slot. It did not miss. The entire sequence, picking up the egg, transferring it, and placing it down, displayed a level of control and precision Gen2's potential for real-world applications. It wasn't just about brute force. This robot could potentially handle delicate tasks with surprising finesse. The Optimus Gen 2's hand movements were a glimpse into a future where robots can not perform complex maneuvers, but also be able to determine the right amount of pressure to apply to be able to handle certain objects. Now, as you can see, Tesla's latest video showcases Optimus, their humanoid robot, independently sorting 46 battery cells. The clip starts in a controlled training environment, where Optimus practices the task. Later, the scene shifts to a real Tesla factory, with Optimus sorting batteries on the production line. While Optimus carefully picks up each battery and places it in a red crate, it's important to consider the bigger picture. This might not be the most efficient sorting method used in factories currently. It's more likely a demonstration of Optimus's grasping and object manipulation skills. However, it hints at Tesla's future plans for the robot. It's easy to imagine over repetitive and potentially tedious tasks currently performed by humans in factories. Tesla's approach to training Optimus, the humanoid robot, involves a unique method. While the goal is to achieve autonomous operation, the current process relies on human input. In the controlled environment, a human operator wears sensors and a VR headset, mimicking the tasks Optimus needs to learn. Optimus then mirrors these movements, training its neural network to perform the tasks itself in the future. It's likely to be a time-consuming process, especially considering the large workforce present in Tesla's factories. Next thing we have to mention is the battery capacity. The Tesla Optimus is equipped with a 2.3 kilowatts per hour battery, comparable in size to a small electric vehicle's battery. Unlike some rigid robots with fixed energy, Optimus adapts its power consumption based on activity. When idle, it draws about 100 watts, similar to an energy-saving light bulb. This translates to 18.4 hours of continuous operation while stationary. However, movement increases the energy drain. Slower movements like walking consume roughly 2, allowing for around 9.2 hours of operation. Faster movements like brisk walking jump to 500 watts, reducing runtime to 3.7 hours. Running further increases consumption to 700 watts, and carrying heavy loads can drain the battery in just 1.84 hours at 1,000. This highlights the importance of battery capacity and efficiency for robots like Optimus. And lastly, the Tesla Optimus Gen 2 isn't just about muscle and movement. It boasts a sophisticated sensory suite that allows it to perceive and interact with its surroundings like a high-tech. At the forefront of this sensory array are high-resolution cameras. These act as Optimus's eyes, providing it with incredibly detailed vision. But the Optimus isn't limited to two-dimensional sight. LiDAR, a technology akin to a super-powered radar, creates detailed 3D maps of the environment. This allows Optimus to navigate with confidence, avoiding obstacles like furniture or uneven terrain. The bot is expected to have Tesla's full self-driving and autopilot cameras. While Tesla has not added these features yet, Elon stated that a prototype will be released later in the year. With the FSD camera system, which relies on machine to improve its object recognition and pathfinding abilities, the Optimus will be learning from its experiences as it interacts with the world. This could lead to better decision-making and increased autonomy over time. And that's all we have on the updates of this Tesla Optimus bot. Let us know what you think about its capabilities. Don't forget to like and subscribe, and we will see you in the next video.